Hello, ReactNext, and welcome to Advanced Patterns, Moving Beyond Containers and Presentational Components. I really hope that when I put the slide together, I didn't oversell this. The interesting thing about React developers is that they span a wide spectrum of experience, so I hope everyone gets something out of here today, and if at the end of it, you didn't feel any of these patterns were advanced, come to me and we'll hire you. Usually when I talk at conferences, I get lucky enough to have like the second last talk of the day. And something I really love doing is mentioning things from previous talks, having a bit of fun. There's only been one talk really so far today, so the only thing I can really mention is fish. That was a beautiful presentation, Ben, so thank you for that, and thank you for introducing all of us. Right, my name's Robert. I work at GoDaddy. That picture was taken a long time ago in a galaxy far away. That's me meeting BB-8. Turns out that galaxy is in Florida, in Orlando. On the left there, you've got my wife, Karen, and I would really appreciate, again, trying to set up another tradition here today, if you guys can help me out, like you helped Ben out with the squats. Karen knows I'm coming to this conference, but she struggled to believe I was talking at it. So if I could get you guys all, I'm just going to take the camera and pan across, and if you can all just do like a hi, Karen, or a hello, Karen, that would be amazing, and I would appreciate it a lot. Ready? Great. All right, 1, 2, 3. Thank you so much, everyone. The next slide I put in because I've been in Tel Aviv for a couple of days, and I see everyone seems to have dogs here and really love their dogs. Those are my two Dashuns caught in bed at 11 a.m. I'm from Johannesburg, South Africa. We do not have lions roaming around in the streets, just to clear that up. I actually saw a chat message on our local Slack where someone had seen a sign saying, "Beware lions," and didn't get out of their car. So I feel it's my obligation just to tell you there are not lions everywhere. Right, so the team I work at GoDaddy works on products that help our customers serve their customers. So we initially started out with a website builder project that can help customers build websites to serve their customers, but our teams are expanding to address more business needs for small to medium business owners. And we build these products using a variety of languages, including Node, React, and some Ruby and Rails. But now I'd like to tell you about how I got into React and my journey and how it started. I started React before it was a major version number, back in like the V12 days, and I started using it for a project called Reminder App. Reminder App was an interactive calendar that allowed practices like doctors, dentists, hairdressers to replace their paper booking book with a digital booking book, and it added some smartness around messaging. It turned out that a missed appointment cost a doctor a lot more than a cancelled appointment because you can slot someone else in if you know someone's cancelled. So that was the main premise around this. Before a customer would be coming for their appointment, we'd send them a message saying, "Hey, are you still coming?" If they replied yes, the appointment would go green. If they replied no, it would go red, and unconfirmed as purple. And this helped our customers to reduce the number of just no-shows and empty time. But what made this an interesting project was we first started out rolling it out in jQuery as a minimum viable product, and we realized, well, it's time now to turn this into a real productionized application. And we were trying to evaluate which framework we would use for this. We started out trying Angular and Ember, and React, in the end, was the one that clicked for us and just made the most sense. And one of the reasons for this was this philosophy behind React, that you would send data down and actions up versus model binding in the other frameworks. And this just made sense to me because the model binding could get so convoluted, keeping track of which field on your UI is bound to which part of your model, adding computed fields, and you could really, it builds a very complicated application. And at around the same time, Facebook released their spec of the Flux framework, which allowed you, again, to model data down, values up, and a way to store your state in an external state store from your application. The problem we ran into with Flux was that the initial spec wasn't very clear on everything, and so we rolled our own implementation, and like many people, we implemented multiple stores, as this is the way you're supposed to do it back then. And we immediately ran into race conflicts between the multiple stores. A little bit later, Facebook released their own implementation of the spec and had mechanisms to get around this, but before that time, we switched over to Redux, which got around this problem by having a single representation of state and actions that would come in and reduces that would update your state. But this was the time where I got introduced to my first React component pattern, and that was presentational and container components. So when we started working on Redux, we started finding out that they recommend that you keep your stateful components separate from your pure components or your stateless components. And I'll just read this to you. This is from the Redux documentation. React bindings for Redux separate presentational components from container components. This approach can make your app easier to understand and allow you to more easily use components. And there's a little bit more information around the differences between them. On top is, I think, one of the most important, how things look for presentational components and how things work for container components. And this was great. I started rolling out a whole application using something similar to this. We would have our presentational component on top that just has some data in, UI out, and then the container component here at the bottom. And this was great. This was the first pattern we learned. So just to establish that pattern a bit more formally, we've got container components that know things about outside of the context of them. They wire up your application to side effects or external state. And presentational components that have everything they need passed into them. So as time went on, I started developing like an intuition around these things and certain guidelines for how you write React applications using these, and came to replace my understanding of containers and presentational components with class components, which should be an indicator that something odd is going on here. Something is more complicated than just state being passed into render UI, and then replacing all presentational components with function components. So this was, for a long time, a signal marker in my code base. If you see a class component, it means here be dragons, here's something more complicated, pay a bit of attention. If you see a pure component, it's easy, it's just rendering UI. Right, so I've said that class components do the wiring up to side effects and know about the context outside, but if I jump a couple of slides back, you don't see any classes here, right? And I'm assuming many of you have used Redux and have an understanding of what's going on here at the bottom. If I can just get a show of hands, who knows and understands what a higher order component is? Great, that was my sense. Like when you're writing React, you come across them. Who's written their own higher order component? Amazing, great. Okay, cool, so where is the class? Well, it's in the higher order component, right? So that function, connect, returns a class component that wires it up to the React context. And now we'll ask like, okay, cool, I said that class components represent being connected to something outside of the component tree. Is state really inside the component, right? So that's another reason you use class components. You use them to do local set state. And it might feel initially that state is inside the component. You don't see it leaking out, you can't access it from anywhere else. But in my opinion, it's external to the component because it ties into the React lifecycle. There's nothing you can do inside a pure function component that can trigger React to re-render. But inside a class component, because you extend React.component, you have access to the React lifecycle hooks and to trigger them. So this is another reason why I see class components as like the powerful version or the dangerous version or the side effectful version of components, and a pure functional component as a much weaker, much safer, much easier to reason about version of the component. So as I say, where is the class inside the higher order component? Inside Redux, it's in that. Here's an example of a higher order component where it's a function that accepts some sort of setup and returns a class, which is a React component, and then just does something inside of there. But now I've given you a whole bunch of noise. I've said there's pure components, container components, presentation, higher order function, class components. Let's just take a step back and start out with two classes of components. Classes of components. We'll start with pure components and side effect components. And with that, I'll say we've reached our first milestone. So if we start out with a graph like this, we're going to look at a couple of patterns today, and they're all going to fall into one of these two, side effects or pure components. How many times have you been working in a React code base, put something together, and then been like, I don't know how that worked or why that worked. It doesn't seem like that should have worked. I'll give you an example. So Victory Chart is one of my favorite React charting libraries. It took the approach of going like a React first, a React mindset around charting libraries. A lot of libraries will wrap something like D3, but Victory Charts is from the ground up a React version to draw SVG charts. And the code to do this chart over here is up on the screen now. We've got a wrapper called Victory Chart. It's got a height of 390. and then it's got a victory line that passes in some data, and a victory scatter that passes in some data, and a size. And like that makes sense to me to draw the middle part, right? We've got a line and a scatter plot. We've got the size for the dots. We know where the line's coming from. Cool, I get that. It's over there. But where's the code for these things? How does it know that based on my data, 5 is the maximum in my chart on the X and Y axis? And how does it know on what ticks to render? To me, this looks suspiciously like bidirectional communication, like child components speaking back up to their parent components. And this had me feeling a little bit worried and a little bit iffy about this being actually the React way. And it conflicted with one of the things I love about React development, which is the data down, actions up data flow. It turns out, though, that victory chart isn't doing communication from the children back up to the parent. Victory chart, the wrapper component, is just interrogating and looking at the data it gets passed, which is its children. If we take the top example there, which embeds the children inside the victory chart object, it's equivalent to doing what's at the bottom here, which is passing something into the component. Anything you put between the open and closing tags is going to be passed to the component as children. So that means that the victory chart component has access to everything that's passed to it. And victory chart then interrogates its children and finds out, if you haven't passed it on the top level, what the data is. So each child component exposes its props via a selector, and because it's been passed in data, the victory chart component can interrogate that. So really, it's not an impure component, and it's no side effects. The child components are not speaking up, they're not speaking out. It's just being passed into the parent component, and the child component is being read as if it's data. And this will be the first pattern that we're going to add to our graph, child-aware components. The victory chart is a good example of them, but I'm sure you'll come across other libraries that use this sort of pattern. So let's add it to the chart. We've got pure, and the first one we're going to look at, or we've looked at, is child-aware component. I must just add, when reading through the victory chart's code, I came across this comment, and I thought I should share it. You know, get new children, the old ones were bad. I think any parent would chuckle at reading that. All right, so moving on, I decided at some point that I wanted to use this pattern for my own component. And I wrote a wizard component. The behavior of the wizard component is something like this. It starts with one thing on screen, and when you click next, it shows the next thing. Right, and the code to render that out would be something like this. And again, you're wondering, like, where is all the code for the next button? What happens there? And it turns out it's all in the wizard component. But the wizard component's a little bit smarter than that. So the code is up there, but I think this is a bit much to take in. So let's focus at first just on the top part, right? This is something that if you've worked with React class components, you should be comfortable with. It's an initial state, and then just a function that when called sets the state. We're taking a further step, which starts out at 0, and then the function takes in a further step and moves the wizard forward to that point. The real magic lies in the bottom part over here. So let's zoom in on that. I think even this is a bit much to take in one go. So let's focus first on the top part here. Here's some of the components where I think you start finding the majority of React developers may not have touched them. Right? So react.children.toArray is a function that will take the children property that you've been given and convert it into an array. Why is this important? Well, sometimes, or almost always, your children are going to be a top-level node, and sometimes it'll be a list, but you don't know whether it's one or the other. And this is a helper class that wraps your children in an array and gives you the ability to map over them, to filter them, to reduce them. It turns them into data, essentially. So we're going to do that to our children, which is the step components, and then we're going to do a reduce function over them. The first part of the reduce function is just going to check, based on the further step we're on, should we show this step or not. So we're going to go through each step and check, are we on this step? Are we past the step? If we're not on or past the step, don't render the step. Just return what was previously the result of the reduce function. And here's the real magic, right? So if we are going to render this, what we're going to do is use the react.cloneElement function. And really, if you look at it and you've got some intuition around it, it makes sense. It takes one of the child components, it clones it, and it allows you to add props on it. And all we've added here as a piece of props on the child element is the onComplete function, which wraps an anonymous function that takes index +1 as the next step. So essentially, we're going to pass each step a function that when you click it is going to move the wizard's further step one forward and render the next step. This pattern, which is a superset of the child-aware component, I'm calling child or children enhancing component. And we've put it up on the screen. We're looking at, we've got pure components, child aware, and child enhancing. I do want to just give you a caveat here, a warning. This sort of code where you're doing these sort of non-intuition things where you kind of hide some of the magic away from your users, this is framework level code, right? This is like why it's used in victory charts or in a wizard component. I would not expect to find this sort of code in your day-to-day application because it removes explicitness, right? You need to know a lot about how your children work and things like that. But conversely, if it gives you an API like this where you can write wizard and step, and done, it's immensely powerful if you can package this up, make it very clear around how your users are supposed to use it, and then you can do that sort of thing with the cloning of elements behind the scenes. But it really does lead to like some confusion sometimes. We have an internal component library at GoDaddy, and some of the components, are a little bit too smart for their own good and make assumptions about what you're going to pass into it. And when you do this sort of thing, you're limiting the scope of what your users can do with your components. The most powerful component for reuse is a pure component. And the next one up is going to be a class component. But the moment you start doing these child enhancing or child aware components, you're putting restrictions on what the children of that component can be, which means you're putting restrictions on the way they can be used. So by all means, play with this, use it, but be aware that it's dangerous or it's non-intuitive for a lot of users, and don't scatter everywhere around your application code. Okay. So far we have looked at all pure components, but none of them have really been presentational components, right? For me, presentational components is about data in, HTML out, like how things look, markup style. So I'm just going to put that up there as the second set of the pure component pattern. Right. The next one we're going to look at, up on the screen now, is it's a way for you to, if you can't get by with reactive design, with responsive design, to move over to reactive design. So say you've got two layouts, one for mobile and desktop in the same application, and really doing the responsive styles is just way too much maintenance. The layouts are completely different. You can maybe get by with it, but it makes the code a lot harder to maintain. There are circumstances where you just want a different layout. And if you're moving in and you're working with code splitting, something like this could be even more powerful, where for the mobile, at this point, you make a decision, this is the mobile interface, it doesn't have all the dependencies, it's a much smaller package we're sending down. So if you look at the code there, we've got a desktop version of our component, a mobile version of our component, and a responsive helper that's going to take them in and export a wrapped my component. And what this means is that in parent components of this, I can just render my component and not have to worry about which one's going to render. It takes care of itself based on which device it's in. Here's the code for this. It's pretty simple. We're just using the match media API in browsers, checking if it's mobile. It's really, really simple because it only assumes 2 breakpoints. And based on the media query, it's going to return either desktop or mobile. This sort of component I'm calling a decision component. This is perhaps a more specific or advanced implementation of it, but decision components, essentially, you move it outside of your component, it makes a decision and renders 2 separate trees based on that. It allows you to simplify each of those cases that you're rendering. So each individual case no longer has all the conditional checks in it. It's very powerful where you would have had something like 13, 14 conditional checks in your component, split them into 2 simple components, remove the decision a layer up. It is a trade-off of simplicity in the component versus dryness and do not repeating yourself. Because you are going to have 2 components that serve a similar function, and you need to remember they're both there, but they'll both be a lot simpler and easier to maintain. So use it with restraint. It's going up under the pure component. Right, moving over to the side effect components. These might be the more interesting ones. But before we get too far in, I want to just go over React context. Again, hands up, who's used React context, written their own React context components? Slightly fewer hands, but I'm sure most people know what it is, and if you've touched Redux, Redux wraps context for you in a way that you don't need to see, but essentially here's the modern React context API. You create a context based on a default value, you get a provider out of it and a consumer out of it at the bottom, and so you'll wrap your application in the provider, and then inside the consumer you pass it a render prop and it'll pass the context back out to you. A real-world example of this that we've used is an analytics provider component. We needed to send down a track function that could be used anywhere in the application. So we created an analytics provider, wrapped the entire application, and that set up the tracker at application boot up. And then inside, for instance, an example download button, when you click it, we, at the bottom there, have wrapped it with tracker, which is just a higher order component that is pulling the context out and then passes it into the component and allows you to track it. So I'm referring to this sort of pattern where you use context outside of data management or Redux, where you're passing in a service that your component needs across the application tree as the service injection component. It injects a service anywhere in your application where you need it. Something else you could use this for is authentication, maybe feature toggling or anything like that, A/B testing. Inject a service from outside into your application tree. And it's going to go as our first side effect component. Right, so if you combine the previous patterns, we can end up with a feature toggle component or an authentication component. It's a composition of the decision and the service component. And here's how it might look. We've got the new component that we only want to show to our beta users. We've got the old component that we want to show to the old users. And we've got this with feature higher order component that takes the feature name and knows how to toggle on it based on the service and renders either new or old. And then at the app level, you would have a provider that would pass down the service to the higher order component. Like this. So we've got the feature service, very much like the application, the analytics service. Injected. The next pattern I would like to talk about is an event listener component. It's similar to the service injection component, but essentially what this can do is it'll wire up a subscription to some sort of subscription observable, and it'll call something inside your component repeatedly. Now, this might sound anti-React, but in fact, you can get a lot of high performance out of this if you're doing things like animation or anything where you need real-time interaction with your component. And it turns out this is what Redux does. Right? Redux is essentially a eventing bus, a messaging bus, that every time a message comes in, it does some stuff and then it broadcasts further subscriptions. So Redux is actually, this connect function is an example of an eventing function that causes the components to re-render wherever you've connected it, along with some optimization of performance. So I'm going to put that as an event listener. Think of it as Redux. It's another side effect component pattern that you can use. All right, next we're going to move on to styled components. And if you've been paying attention to the flow of things, you know where this is going to end up. But if you look at code like this, intuitively, would you think the styled components, which is the top there, is just taking in some styles. It creates a new component called card, which I didn't use. But if you look in the React dev tools, this is what it's going to render out as. It's going to render out as style.div with the ID that you've passed it in. This doesn't look like a side effect component, right? This looks like a pure component. It's taking some styles, it's passing it down to my component. But if you look at how styled components actually works, what happens when a styled component renders, it grabs those styles that you've provided it and appends it to a style tag in the header, thereby mutating the DOM as part of the rendering process. And all your actual element at the bottom gets is this abbreviated ID of what that class is. So really, it is a very side effect for component. It does a lot of optimization around how to toggle those styles on or off and how to render them. So it's definitely a side effect component. And another example, I'm just going to drop it in there under side effect components. Right, so I think this is pretty much where we're going to end today. I've left a lot of space for you at the bottom here to find your own advanced component patterns. But I've given you some ideas of like what patterns are out there and what you might be looking for. But why? Why should you care about these sorts of patterns? Why should you keep this in your bag to sort of analyze React code? It turns out that humans are not very good at thinking of multiple concepts at once. The magical number 7, plus or minus 2. This is one of the highest quoted psychology research papers that say we can only really keep 7 working concepts, plus or minus 2, in our brain at a time. And using patterns like this allows us to wrap up all the niggly bits, all the complicated, confusing bits, inside a box, label it with a pattern name, and treat it as one concept. It allows us to work with a lot more complicated things at a time. And I really like to think of these patterns as similar to Lego bricks. Right, so I've got a service injection pattern. I don't need to know and keep in my mind how the service gets down to my component. I know how it works, I know what it is. It's now a Lego brick. That's one concept. I don't need to keep React context in mind. I don't need to keep where it was initialized in mind. It allows us to wrap, patterns allow us to wrap complicated concepts into a thing that we can recognize and keep track of just as one. And it also allows you to reduce the number of times you need to ask, how did that component do that? The next time you see a component where it's missing the code to put in the X and Y axis, but it's based on the children, you might think now, maybe I just checked what props its children had. And that's the idea of these patterns, to recognize when a developer is doing something that you might not be familiar with, and now you'll be like, I know how that works. I'm probably expecting to see a react.children.to array somewhere in there, or a react.children.clone. So I just want to recap quickly again at the ones we looked at. We started by saying, let's split some of our components into pure and side effect components. Then I introduced the child-aware component with Victory Charge that was aware of what its children's data was, and the child-enhancing component, which was the wizard component, which went a step further and added extra props to its children based on what it was passed. We then went on to just add presentational components as a separate form of pure components, and then decision components, which really are just a conditional based on what you put into it, but it allows you to simplify lower down components. We moved over to side effects components. I introduced you to a service component that allows you to inject a service at any level of your application, an event lister component, which you might reach for if you need to do high performance observable work, and remember that Redux uses this, and then styled components as an example of a side effect for component. But why did we separate pure and side effects? In my opinion, pure components are easier to reason about, they're easier to test, they're easier to compose, and they're generally simpler. And if we can keep the majority of our code in this mindset and reduce the complexity into a thin layer of side effect for components, code bases, in my opinion, will be more maintainable. I was introduced to this concept of a functional core imperative shell by a software engineer called Gary Bernhardt, who has an amazing website called Destroy All Software, where he puts out screencasts. And I highly recommend you go and watch the talk called Functional Core Imperative Shell. It reaches beyond React into all application development and keeps you along the lines of why you want to separate pure components from side effect for components. He also has another great talk called Boundaries, which is around the same idea. And then, like the million-dollar question, right? How do hooks affect this? So who is familiar with hooks? Can we just get a hands up? All right, I'm going to blow some of your minds then. I feel like ReactConf. So at ReactConf a couple of weeks ago, the hooks API was introduced. Essentially, it's a bunch of functions you can call inside your functional component that will expose side effects to you. Up on the screen, we've got one called useState. So we've got a pure functional component called example. It calls useState as the first thing it does, which returns to you a count and a set count. Count is the actual value of the state object, and set count is the function you're going to call to change it. And then the 0 is the default value. And at the bottom, an example of how you'd use them. You've clicked the button that many times, and then you just call the function. This is great. The first time I saw this, I literally did like somersaults. I was like, woo, this is going to make React Dev a lot easier. And then I realized, but hold on, how do these functions work? And they are a little bit magical. But more important to me, I pulled up earlier to a slide that says, class components are the complicated ones. Class components are the ones that you need to stop and be careful around because they're doing some sort of state manipulation or side effect behavior. And pure components are easy and simple. But if you look at this one, this is a pure component that suddenly has state in it. Thank you. See, I got too excited about pure component, about hooks, and I knocked the stage over. I guess the only real way that this is going to change things with hooks is that you can no longer look for class components to indicate side effects, right? You're going to have to look for class components as the old way to indicate side effects, and hooks is the new way. And they're always going to be at the top of the function because they have a lot of restrictions around where you can use them. So how do I feel about hooks, given this is my view of the React world, a pure and then an impure world? In real code bases, that split is almost never as clear. There are times where somewhere deep in your code base, you're going to want a piece of local state that doesn't necessarily need to make it back up to your Redux store. And hooks make side effects a lot easier. I will say that most of the patterns I presented today are more useful the bigger your React application gets. For enterprise applications, they make more sense. For small applications like a widget you're going to embed on a page, hooks are going to be really powerful, and it's going to allow application developers who don't build big applications to quite quickly add side effects to their components. So I'm really, really excited about hooks, but just because they're there doesn't mean you need to stop separating pure from impure components. The value in having pure components is they're easy to reason about, they're easy to test, and they're easy to compose. React hooks change that a bit, but keep your components separate. Do the side effect for components as wrapper around a pure core, and you should be fine, and we're excited for hooks. And that's all I've got for you today. I don't know if we do questions here. I think I'm out of time. If there are any questions, do we do questions?
Nope.
Nope.
We're out of time.
Great. Thank you very much, everyone.